Hi, I'm Mike Stanzik and this is Digital Electronics Classroom. In this video we're going to be looking at ripple counters again, but this time we're going to be looking at JK flip-flop ripple counters. And again, we have to worry about two things in our design. One is we have to make each of our flip-flops toggle, and the second thing is that we have to make sure that we trigger the next significant flip-flop at the appropriate time to do an up count or a down count. And we'll look at both of these things in this video and when we simulate on Multisim Live. So let's get started. Alright, so we have a JK flip-flop ripple counter. And this is an asynchronous counter because not all of the flip-flops get the clock. And first thing we have to do is toggle all flip-flops. And so set them to toggle. So how do you set a JK flip-flop to toggle? Well, JK's operation table shows that if I feed a 1 into both J and K, this will be a toggle. And so we have to send this a high signal, a digital 1 if you will. And so we'll do that by sending it to both the J and the K signal. We'll send that 1 in our simulation. Okay. The second thing we need to do is we need to make sure that we toggle the next bit for an up count when Q goes from 1 to 0, and for a down count when Q goes from 0 to 1. And so this here would be, kind of got a little bit offline there. That's okay. So this would be what we would call a negative edge, and this one would be a positive edge. And they would look like this and this respectively. It likes to do that. I'm not sure exactly why, but it's the invert of that right there. Okay, so let's go ahead and build them in Multisim and let's see how these guys work. Great, here we go. So I'm going to pull out some flip-flops, JK flip-flops. And we'll go ahead and get them set up. We can put this one near the top. Let's give us a few spaces in between. Okay, that looks great. So to make them toggle, I got to give a 1 to all the JKs. And so I'm going to take a digital constant right here, and I'm going to leave it as a 1. And then I'm going to feed it into all of the JKs. And so we'll start here with this K, go all the way up, and then I just go ahead and connect it to that line. So all the JKs will be 1, which will set all 4 of these flip-flops into toggle mode. And we noticed from the video about binary counting that we have to make them toggle if we're going to do a count, whether it's up count or down count. So when I look at this point, this thing is set up to do either an up count or a down count. What really matters next is how I connect the bits together. Just a note, the least significant bit here is going to be on the top. So it's A0, then A1, then A2, then A3 as we go down. All right, so on A0, I'm going to send it the clock. And so we can see what's happening here, I'm going to make the clock another digital input so that I can manually clock it. Now here's the thing. These are all positive edge triggered flip-flops. And if I want to do, and we're going to do an up count first. If I want to do an up count, I've got to make sure that when I get a negative edge out of Q, that I clock the next bit. But a negative edge won't clock the next bit here. I need a positive edge. This is why we use Q bar for this situation. So I'm going to connect the clock to Q bar of the previous bit, and I'll do that for all of our And this says that when I do experience a negative edge on Q, we will trigger the next bit with a positive edge coming from Q bar. To see what we've done, I'm going to put a hex display out here. And a hex display is just a 7-segment display that has all of the decoding already done for it. And so I'm going to put the most significant bit into D, and then to C, then to B, and then to A, like so. Okay, and now we're ready to go. Let's see this thing clock. So it starts at 0, then 1, then 2, then 3, then 4, then 5. It's counting upwards like we wanted it to. And it's going to go all the way through. This is a hex display, so now it starts to show the hex characters. D, E, and F for 15, and then we're back at 0. So there is an up counter. And so pretty easy to set up. And watch how easy it is to switch between an up and a down counter. The difference between an up and a down counter is that we're going to trigger on a positive edge coming out of Q. And so a positive edge is enough to trigger the next bit. And so instead of connecting the Q bar, we will connect the next clock to Q. So that is the only change we need to make. And if we make that change, now when I run it, it's going to count down. F, E, D, C, B, A, 9, 8, 7, 6, 5, 4, 3, 2, 1, and back to 0. And there you have it. That's how we connect up a JK counter, a ripple counter, counting up and counting down. I hope that had value for you. I'm Mike Stanzik. This is Digital Electronics Classroom. Be sure to like and subscribe, and have a wonderful day.